Thank you, Julie, for that introduction, and thanks for coming to this talk. My name is Shyamindu, and I do a lot of work around data literacy and making sense of the world through data. And this is sort of like a reflection, a high-level reflection of a bunch of the work that I have been done over the past few years. And before even like starting anything about the talk and the work, I just want to acknowledge all the, like I'm giving a solo presentation here, but this work would not have been possible without a lot of the students that I've worked with, some of my mentors that I've worked with as well, whose work shows up here. So I just wanted to acknowledge that none of this would have been possible without their support, advice, and kindness. So I wanted to start off with a couple of vignettes of what I term as living with data. So we live in a datafied society. Like data collection is incredibly easy. Processing data is also easy. So every aspect of our lives are being analyzed, like measured, analyzed in different kinds of ways. So this is an incident from a few years back, 2021 actually, September 2021. I was living in North Carolina then. And in September, I received this email pretty late at night from my water utility, alerting me that there might be a leak in my house, a plumbing leak. And turns out that they were actually sort of analyzing very fine-grained data about the water usage pattern in my house. And indeed, it turns out that there was a water leak, and I would not have actually like found this out like without this email, or or maybe I would have like found it out like with a very large bill at the rest of the month, at the end of the month. So I was very grateful that like this came through, and this is one incident where sort of like which shows that like it can be useful to like have this sort of like data analysis is happening around you, but then like there are enough counter examples that like make you perhaps stop and think a little bit more. So this is a story, a news story from the Seattle Times, closer to home, and this is from 2016. And this article is about people in Seattle, or in King County actually, who were getting letters sort of with threatening or somewhat threatening legal language, suggesting that they might have a pet, and they have not registered that pet with the local government, and they might be fined as a result of that. As this story suggested, turns out that one of the people who were sort of interviewed for this story did not have a pet. Their pet had died many years ago, and it wasn't clear, initially at least, why these letters were being sent out. And turns out that the local government authorities were actually using marketing data to like figure out who might actually potentially have a pet. So it was all sort of probabilistic, and sending out letters based on that sort of inference. So marketing companies would gather data about purchasing patterns. So in this case, someone had bought pet food or a dog toy for a friend's pet, and they were on a list as having potentially an unlicensed pet. So again, like perhaps there were like very good intentions behind it, and but this sort of like makes you think a little bit, and and I would encourage you to like pause for a moment at this point and like think a little bit about like what could go wrong for both the examples. There are like a lot of things that like spoiler alert, there are a lot of things that can go wrong. So, sorry, my slides are not. Dramatic pause didn't work as I intended. So the pet warning letter, especially the wording, was probably not the best idea, and and obviously like that caused a lot of people to get concerned, and were led to some confusion at least, because it was pretty clear that like not everyone who were getting these letters they didn't have pets. But what about the helpful notification from the water utility? The reality is that it definitely saved me a bunch of money. Like if I hadn't detected that water leak, I would have gotten a pretty large bill at the end of the month. So it's helpful. It was helpful to me. But that particular user's data, especially at that granularity level, like they were like, like probably getting like hourly data about my water usage. That can be used to make a range of inferences about my life, about my very personal aspects of my life, like, like who I have as visitors, or like when I have visitors, like are there like people staying with me over the weekend, things like that. And I may not be okay with that sort of like inferences being made about me. And regardless of whether the inference is right or wrong, like going back to that sort of pet ownership case, sure, like, like some of those like people probably did have pets and probably didn't register their pets with the county. But even then, like, like those questions still persist. And generally, when I'm agreeing to this kind of data about my personal life being collected and or analyzed, if I have the choice, sometimes I do not have this choice, I'm essentially making a decision about trade-offs. Like after I received that email notification from my water utility, I did remember that, oh, actually at some point I did sort of like, I think I did opt into that like thing. And it was a trade-off, like I was okay with my like sort of like fine-grained water usage patterns to be analyzed. But I also was aware of the fact that like, like it could be made, it could be used to make other inferences about how I led my life. And I was, like I saw it as a sort of trade-off, and I was okay with this. I felt that like, like the benefits outweighed the sort of risks in this case. And this leads me to this sort of like a central argument that has guided my work so far, is that, like we are living with data, whether we like it or not. But living with data requires an ability to recognize both the possibilities and the pitfalls that come with data. And not just data, but data-derived processes, data-driven processes, and so on. We are staring at a world where there are like a lot of like new possibilities. There are like, like almost like sometimes like science fiction like new possibilities. But there are like, like deep risks involved as well. And how do we think about these sorts of like, like trade-offs, and how do we learn about these trade-offs, and how can we support young people who will be growing up to live in an even more data-fied world? How can we support them to think about these sorts of possibilities and pitfalls? And this is something that, like a lot of scholars have studied throughout, especially over the last 10, 15 years. There has been this emergence of an entire sort of subfield called critical data studies, and I'm not going to do a lit review because that's going to be a completely separate talk on its own, but I just wanted to acknowledge that. And some of that has also sort of like engaged with education as well. And my primary research focus has been to connect conversations in critical data studies and critical computing to learning and design, especially for young people. And I draw the other sort of aspect of my work where I focus on sort of like, like how to support learning, draws from theories of learning, especially constructivist theories of learning and critical pedagogy. So, inspired by Professor Bjorn Hartmann's Venn diagram, which I don't think exists on his website anymore, but I was very inspired when I saw that many years ago. If I were to draw a Venn diagram of what kind of areas and disciplines that I draw from in my work, I would draw a Venn diagram that looks like this. And most of my work is at this sort of like intersection, like, like this sort of like small spot over here. But sometimes I do like, like go into like one of these like broader circles, but my primary focus is on this space. So the overall question that guides a lot of my work is how can we design learning experiences and tools that support learners in not only learning about data, but also in questioning and critiquing data and data-driven processes. And reflecting on the sort of like bunch of work that I have been doing over the last few years, I see two broad but interrelated strands in what I have been doing. And obviously they are interrelated because, like it's very hard to like draw like very well-defined lines. But one body of work is more about sort of building new systems, designing new systems, and then trying it out with learners to like see how they make use of those systems. And the second, which is very much related to the first strand, is to consider what it means to be literate and or fluent with data. Now, data literacy is a topic that a lot of scholars study. People have come up with various definitions, like a lot of disciplines have their own definitions of data literacy, and I do draw from that work. But there are also things that I feel that like are often like not paid as much attention to and so on, which sort of I try to highlight in my own work, and I'll explain a little bit more about that in a few seconds. But let me talk about strand 1 first, which is more of my design work, more of my systems development work. And I'll describe a couple of systems and then also sort of like insights from the use of those systems. So Scratch Community Blocks is a system that I built, and to set some context, this was developed in the context of Scratch, a programming language designed for young people. And it's also an online community, so people can share their Scratch projects in an online community. And it's used by millions of kids from all over the world. And a lot of my dissertation work was centered on Scratch, and Scratch Community Blocks formed a part of that. And I was a part of the Scratch team at MIT for my PhD, when I was doing my PhD. And Scratch Community Blocks was a system that I developed and designed that added a new set of programming blocks to Scratch. So it basically extended the language, the programming language. And the idea was to allow Scratch users to do their own data analysis on the data about their own Scratch online community. So it allowed access to data about the Scratch online community, so people could, for example, analyze, or visualize like how many followers they have had over time and so on. So another contextual thing that's important here is that the Scratch online community was designed as a social network, so you could like follow other people on Scratch and like their projects and so on. Now, when I was designing this programming language, one of the key design considerations was to be consistent with the rest of Scratch, the programming language, because I was sort of fundamentally extending the language, but I wanted to like keep in line with the conventions and the metaphors that Scratch used. But I was also at the same time being sort of like trying to remain within the constraints of the language. So, for example, Scratch did not have support for, and does not yet have like support for tabular data structures. So if I'm thinking about data literacy and working with data, tabular data, like tables of data, is pretty important. Scratch did not support that, so how do I work around that? So I used metaphors that were already being used in Scratch. So Scratch primarily followed an object-based paradigm, where you had on these sorts of on-screen characters who had like positions on the screen, who had various properties associated with it. So you had an X position, a Y position, a size, which direction it was pointing to. So these were all positions of sprites on Scratch, of Scratch. I sort of borrowed from that particular metaphor, and also borrowed from established software engineering conventions such as object relation models and so on, ORMs, and essentially came up with a set of blocks that did not directly expose tabular data to the Scratch users, but still managed to allow them to sort of iterate through the project shared by a given user, or iterate through the followers of a given user. All of this data was already public. This was only a way to access this data programmatically. And I'll show you this slide shows a couple of examples in how this works. So for example, in the first example that's being shown in the screen, what's happening is that someone is trying to, this code that's being shown as script A, it iterates through all the users who are following a certain user, another user on Scratch, which is the Scratch team user, and it prints or does the equivalent of printing on the screen only if the country of the user is Spain. So when you sign up on Scratch, you can indicate which country you're from, and that's publicly visible on your profile. So it basically shows the self-reported country. It filters by the self-reported country of a given user's followers and shows them on the screen. So, like this worked, and we ran a bunch of studies around like how these were used and so on. But I wanted to sort of highlight this, and I'll come back to this Scratch Community Blocks project later on. But right now, I wanted to bring this up because I wanted to sort of like talk about the design of the blocks a little bit. The next project in this sort of like series was something known as, or is something known as DataLand. DataLand is a block-based programming language that focuses on data analysis. So Scratch was primarily focused around working with media. In DataLand, the primary focus was actually to work with data. And the idea was to draw lessons from Scratch and other similar block-based programming languages, but then also remain unconstrained by the sort of like established nature of Scratch. I couldn't change Scratch dramatically because it was already in use. It was being used by millions of kids all over the world. So this was more of a clean slate approach. And you can see from the sort of like screenshot here that tables were very prominently featured, because I was like, okay, I can actually start to work with tables. But I still kept some of the metaphors from Scratch, because from what I had seen from people working with Scratch community blocks, I could see that it's sort of like they were comfortable and fluent with that sort of like metaphor being used. So I had drop downs to access properties where the properties were essentially columns and so on. And we ran a series of workshops here at the University of Washington with DataLand, where the data analysis was done in the context of an existing story. So the idea here was that in order to situate the story, in order to tell learners what the context of the data analysis was and what the purpose of the data analysis was, we came up with a story around the data analysis projects and ran workshops with these. And you can see on the screenshot here that it basically leads the learner through a series of tasks, which is sort of part of the story to help them solve almost something that looks like a puzzle. One of the things that we noticed both with Scratch community blocks and with DataLand was that learners, when they were creating programs to work on the data or use the data somehow, they were starting to reflect on the limitations of the quantitative data that they were using, or on sort of data-driven processes, for example, algorithms that make decisions based on the data. So for Scratch community blocks, one of the users who were using this system commented that gave us feedback that, oh, I love these new Scratch blocks, but however, I did notice that they could be used to exclude new scratches or scratches with not a lot of followers by using code like this. When flag clicked, so that's the way you start a Scratch program, if then users followers less than 300, stop all. So it's a simple conditional, right? And because Scratch community blocks allowed you to measure how many followers, or allowed you to access how many followers a particular user had, this Scratch user who was using Scratch community blocks was concerned that this would introduce possibilities that could potentially exclude new Scratchers or Scratch users with not a lot of followers from existing Scratch projects, and they were concerned about this. In our DataLand workshops, one of the participants commented that we were doing a bunch of data analysis around pet data, pet registration data from Seattle. That's a pattern in my work, apparently. So where they commented that data registered by human, and they may not enter accurate information. For example, they may not be certain about the breed of the dog. So fundamentally, what they were talking about is this phenomena where when we are collecting data, it's often a very human process. Errors happen. Sometimes, ambiguous situations come up. And this particular learner in our workshop was commenting on, how this might lead to information that's not entirely accurate. So these were, again, going back to this question of recognizing the sort of pitfalls of working with data and data-driven technologies. Both of these sort of highlight two distinct aspects of like how like data-driven technologies and data-driven systems introduce a lot of possibilities for us, but also have certain pitfalls one needs to be aware of. Based on a lot of these observations around sort of like young people reflecting on these sorts of pitfalls and critiquing these data-driven systems, we came up with a series of design recommendations, both for learning experiences as well as for designing learning tools to support the fostering of critical data literacies. And I'm not, again, since this is a pretty high-level overview talk, and I have limited time, I'm not going to like explain each of these design principles, but I will highlight at least like one of them, which is adopt community-centered approaches. So going back to my original, the previous slide, when this particular user was concerned about someone being excluded from a given project because they don't have 300 followers, they were speaking with the background or the context or the community value of Scratch being, the Scratch Online community being an explicitly welcoming community for all. So they were sort of like concerned that like this was introducing possibilities where actually some of this sort of welcoming nature of the community can be degraded because of us introducing programming possibilities like this. So it was essentially something being said while keeping the community values in mind. So hence, adopt community-centered approaches. The second strand of my prior work considers what does it mean to be literate and fluent with data. And again, there is a lot of existing work on trying to define data literacy, and I certainly sort of try to draw from them. And there's also, especially of recently, there has been sort of like conversations about like whether data literacy goes deep enough and whether we need another term, for example, like fluency might be, has been suggested as a term which sort of signifies deeper engagement and deeper understanding of data and data's implications. And I want to highlight a few examples where I feel that existing frameworks and definitions have not explored some of the sort of aspects of data literacy as in depth as I would like to be seen. So one of these things, like you may have already noticed by now, that like like I've been talking about data literacy, but programming has been a central aspect, has been central to a lot of this. Like programming with data has been central to a lot of this. And part of this is because like I started to work with the Scratch team, and I was sort of like like a lot of my own training was with like thinking about like like how to support young people in learning to code and so on. But I also feel that like programming can be a pathway to developing fluency with data. For example, again going back to the sort of like like thinking about like what happens if a user with a small number of followers is locked out of a program. It's not a very complex logic. It's a very simple program. Like like it's just a conditional. It's like if a user's followers is less than 300, just stop the program, and that's it. Nothing more than that. But even with this sort of like like this small program, it served as a tool for this young person who was sort of like commenting about this to us to think about the implications of data. So data itself, like the number of followers, sure, like like people have numbers of followers on a social network, but if that number of followers becomes a criteria for inclusion or exclusion, that's an issue. And this sort of like small piece of program allowed this person to articulate the particular issue at hand. And this sort of echoes a principle from about like a design principle that has been suggested for designing construction kits for young people. This is a 2005 paper by Mitch Resnick and Brian Silverman, where one of the principles that they suggest is a little bit of programming goes a long way. And I think this is one of those sort of like classic examples where, like it's not a very complex program. It's just a small bit of logic that sort of opens up this sort of entire new conversation for a learner. Another reason to consider programming as a pathway to fluency with data is to think about like ways in which someone can connect to their personal interests in novel, creative ways. So with Scratch Community Blocks, someone made this data-driven dress-up game where the social metrics of a given users was used to determine the project viewer's purchasing power. So if you had, like 50 projects shared, you would have, like more virtual money to like buy more complicated, like, like or more fancy dresses for your doll. So, or virtual doll. I had like some complicated feelings about this project, but the person who created this project said that I was trying to think of something that somebody had not done yet, and I didn't see that. And I also really like to do art on Scratch, and this was a good opportunity to use that and mix the two together. And like think about like a classic data literacy or data analysis project. Like you are not, it's very unlikely to be like able to like see a project like this. This was like, like completely like sort of like outside of like what I was expecting. It was, like something that I was not anticipating as the designer of the system. And it would be very hard to do it with a tool that like, like is designed entirely for data analysis. But programming gives us access to a much more broader design space. That's sort of like one of the powers of programming. And in this case, we saw that like someone took advantage of that like broader access or access to a broader design space and made something that speaks to their interests, speaks to their interest in, as they say, like doing art on Scratch and connecting it to data analysis. And this idea of programming and data analysis, or programming to do data analysis, has been referred to, the set of skills around these has been referred to as computational data literacy. And we are not the first people to like use this phrase. But working with DataLand, that gave us an opportunity to sort of really tease apart what computational data literacy might be. And drawing from a prior framework about computational thinking by Brennan and Resnick, we decomposed computational data literacy into a set of concepts, a set of practices, and perspectives. So for example, concepts would include things like the concept of filtering data based on a certain condition, or the concept of aggregating data based on a set of conditions. Practices would include things like, like cross-checking the output of a data to like, like make sure that like it's actually like giving a reasonable output. Like tinkering with data, like, like trying out like various like sort of like, like working with a smaller data set to like before like, like unleashing your code on the like full data set just to make sure that like, like you're like getting reasonable results first. Perspective include things like, like data can be messy, or data can be like shaped by human decisions that are often invisible, and so on. So this was a framework that we introduced using insights or using empirical data from our work on from the research workshop series that we ran with DataLand. And partly driven by this, Regina Cheng, who led a lot of the empirical work on DataLand, Regina was a PhD student in HCDE a couple of years back, and DataLand was not the only thing that she worked on. She worked on a range of sort of like projects that involve data literacy in sort of like informal settings. And in a dissertation, she wrote this, she sort of like tried to argue that like, like maybe we don't really need to think, or maybe we shouldn't be thinking about data literacy as its own like single thing. Maybe we need to like think about data literacies instead, the plural. And she was making this argument based on what she had seen on Scratch, what she had seen with DataLand, what she had seen with like people like, like competing with each other on Kaggle and so on. And each of these communities had their own priorities, had their own interests, had their sort of like own set of like idealized skills. And each of these were sort of like, like fell into this bucket of like data literacy, but they were very different from each other. And her argument was sort of like to think, or her call was to sort of like think about, in her dissertation, her call was to think about data literacies and not necessarily data literacy. And sort of like, like building off that to some extent, or at least like indirectly inspired by that, a more recent work that I have been involved with, this was conceptualized and led by McCain Endres, who's a PhD student in HCD. McCain looked at 3 grassroots activists. This is a very different setting. This is like grassroots activists, like working for social change. But they were also sort of like, like operating in a very data-fied world. And from these case studies, he sort of like, like saw that like, like the way in which quantitative data, like knowing the world through quantitative data is sort of like, is elevated. Like, like that's, like it often becomes the case that like, like the narrative becomes that like, the best way of understanding the world, or sort of like the most like sort of like, like the most effective perhaps way of knowing about the world is to sort of understand it through quantitative data. But the reality was that these these sort of like grassroots activists like were bringing in knowledge and information that went far beyond quantitative data, and that led us to make an argument in this paper that like maybe when we are talking about critical data literacies or critical pedagogies around data, maybe one of the central things that we need to highlight is not like a bunch of technical skills, or not a bunch of like things about like thinking about the limitations of data, but also thinking about like like how often it becomes the case that narratives or ways of knowing the world, or epistemologies that center quantitative data as a way of knowing, become the primary dominant paradigm. And that need not be the case. And maybe one of the things that critical pedagogies around data should teach or help us think about is that like like to push back against that sort of like narrative taking a dominant position. So in part of the paper, it's we say that like more so than teaching about data and datafication, then the goal of critical data consciousness pedagogies is to encourage critical reflection on the knowledge already held about a data-fied social issue in order to piece together an understanding of data centrism and how power operates through it. Switching gears a little bit, these threads continue in the ongoing and recent work that I have been involved in. Sort of thinking about data literacies in its various forms, continuing in that spirit and thread, again, like sort of like trying to bucket things into like 2 strands. A lot of my current work falls into this strand of learning from real world data practices, because it's clear like like sort of like drawing inspiration from Regina's dissertation work that like like people have very different motivations and interests and perhaps even practices when they are working with data. So what does that look like? What does that look like if we look at a pretty broad range of contexts and situations? And then also, like I see AI, artificial intelligence technologies as a special case of data-driven systems. And like I feel that like some of the like lessons learned from thinking about critical data literacy and data literacy in general can also be applied to artificial intelligence, learning about artificial intelligence and artificial intelligence-driven technologies. But let me talk about like the sort of like learning from data practices first. So one of the first body of work that we have been working on, and this is with Minna Zaveri, who's here today, is to sort of like look at data practices of undergraduate students. So Minna conceptualized and led this work, and the central argument that this work makes is that grades can be considered as data. We, like in an university setting, or even like in a lot of educational settings, like students are measured in terms of like their grades, and like you students go to multiple classes where they get like a range of grades, and like like those are like aggregated together to sort of like come up with like some sort of like cumulative measure and so on. And practices that the students develop around grades can be considered as data practices as well. So I led a number of interviews and diary studies with undergraduate students to understand practices around grades. And in another study, Mina interviewed a number of creators of grade tools. So these are relatively recent phenomena where historical grade data from universities, and specifically in this case the University of Washington, has been sort of used by mostly students to create tools that help their fellow students, their peers, to make informed decisions about which class to take. So if you're thinking about taking a class by a certain professor, you can actually like use some of these tools to sort of like look at historical grading patterns in that class taught by that particular professor. And both of us sort of like found that fascinating. And like this is ongoing work. So, but our findings so far suggest that there are a range of practices that students adopt around grades, and they are often shaped by perspectives on what grades mean and represent to an individual student. But beyond individual practices, we have also seen these sorts of collective practices, especially by the creators of these grade data tools, where members of the student communities have taken the task of developing grade data tools using historical grade data from the university. It turns out they are actually like using the sort of public records processes in the university to like get this historical grade data, and they are sort of making tools for their friends and peers to like help them like take more informed decisions. Another body of work that I've been also mentoring, and this is conceptualized and led by Murtaza Ali, who's a PhD student in HCDA as well, around what are known as around the computational data practices around who are known as end-user programmers. So end-user programmers is a term that is used to describe people who are not necessarily professional software engineers, but have to write code as a part of their day job. Think about data analysts or like research scientists who have to like work with quantitative data. In fact, a lot of end-user programmers, though like some of them may not be actually working with data, but in fact, a lot of end-user programmers are actually like the reason they are programming is that they have to do data analysis. So we interviewed two sets of end-user programmers. One set being those who are in training, that is students, and those who are active practitioners, so professional end-user programmers. And they were interviewed about their learning to code experiences as well as daily practices. And like one of the things that we found that existing programming curricula do not serve these in-training end-user programmers well. And it was not that like like one of the sort of like things that came up again was a lack of domain-specific programming skills. It wasn't that they didn't like, especially the people who were already established practitioners, they recognized that there's a need for developing good programming practices in general, but what was really seems to be missing are sort of domain-specific programming training with sort of like potentially like domain-specific data as well. The final one in this series is around like focusing on data practices of visualization designers who are working with demographic data, and this was led by Priya Dhwaka. She conceptualized this research as well around visualizing, and the project was to visualize was around the practice of visualizing demographic data. So demographic data is a challenging data set to work with because demographic categories such as race and gender are often quite fluid. They are constructed from, like there are arbitrary categories often that can be influenced by sociopolitical factors, can change over time. And so, like working and trying to like visualize this kind of data can be a complex process. And we found that, like obviously, like the visualization designers working on this were already sort of like were like taking like the complexity into account, but we're also bringing in their sort of like own personal experiences, values, and understanding of power neutrality in politics into their work. Again, like speaking to this idea of like connecting to sort of like the personal identity and the personal interests of learners. And in this case, these are practitioners, but sort of like, like when learners ultimately become practitioners, so like there is a line to be drawn there. And finally, strand 2 of this is to sort of like think about like, like thinking about AI technologies. Everyone is talking about AI. And, like for me, like a lot of like, I see a lot of overlap between like, like thinking about data and data-driven technologies and AI technologies. AI technologies are fundamentally driven by data. So Ayushi Dangol, who's a PhD student in HCD, conceptualized and led this project where it draws from sociocultural theory and critical pedagogy, and again, sort of like going back to that Venn diagram that I showed earlier, and it shows that children can connect their experiences with AI to sort of like, like especially if they see like AI technologies making biased decisions or unfair decisions, they can connect it to like, like broader patterns of biases and injustices in the world. And one of the theoretical frameworks that we used in this work was, again, from critical pedagogy, drawing from Freire and Macedo's work on reading the word and reading the word, where they argue that like in order to sort of like understand a word, you need to understand the world first, and it becomes a cyclical process after that. And we sort of like adopted that position to say that like, okay, like reading AI, understanding AI technologies require an understanding of the world, and given that AI sort of like is sort of like taking over the world in some ways, like it becomes a cyclical process. Like understanding the world also becomes a part of like understanding AI technologies as well. So what does that lead us to? So like a couple of, or maybe a year back, my research group, which is also, it's called the Learning Epistemology and Design Lab, LED Lab, we sat down together and tried to like like update our website, and we tried to like come up with like what's the sort of like like what is it that we do. And we talked about like this sort of like central value of fostering fluency and critical agency in increasingly computational and data-rich environments. And I think like like that captures our work well. And a couple of projects that I want to highlight here that I'm really like like trying to get started in the next year or so is like, one is around like supporting learners in storytelling with data. So with DataLand, we as the researchers or the educators wrote our stories and sort of like gave learners those stories. What happens if learners can construct stories around data as well? Because like a data visualization is a part of a broader story. A data analysis is a part of a broader story. So can we support learners in being able to like articulate and tell those stories as well? And this involves like like working with educators to understand like their approaches in supporting learners in telling stories, but also like building new systems, like potentially like drawing on DataLand to like like support learners to tell their own stories as well. And also I've been playing around with AI technologies, as many of a lot of people are, and like AI technologies can actually like sort of like help you like do data analysis. And what does that mean for developing AI literacy? What does that mean if like I ask like my favorite chatbot to like like plot the like like past 7 days of like weather data in Seattle for me? Like what do I learn in that process? So that's another. And what does that mean for my own development of data fluency and data literacy? So that's another strand of work that I'm looking at. And if any one of you are interested in that, I would always welcome a longer conversation on this. But I realize that I'm pretty much out of time, so I'll close this talk now. Thank you so much for coming, and I'd be happy to answer any questions that you might have.